For each of these integrals, we are going to find an antiderivative. We're going to choose the plus c to be 0, and then use the fundamental theorem of calculus to evaluate the integral. And then we're going to evaluate numerically using a calculator to make sure we got it right. Okay, so the integral from -3 to 3 of x squared dx. So the first thing I need to figure out is an antiderivative of x squared, a function whose derivative is x squared. So that the exponent has to go up by 1. Which makes it 3. And then you have to divide by the new exponent. So we can do a quick check by taking the derivative of what we got here. So I bring the 3 down. It's going to cancel with the 3 in the denominator. And then I get x squared. So I'll get 3x squared over 3. 3 is canceled. All right, now I'm going to evaluate from -3 to 3. So I plug a 3 in first. So that becomes 27 over 3, which is 9. Then I plug in a -3, which is -27 over 3, which is -9. 9 minus -9 is 18. Okay, then I want to use a graphing calculator to check this. Okay, so I do math 9, function integration. I'm integrating from -3 to 3. The function is x squared. X is the variable. Hit enter. 18, which is exactly what we got. Okay. Number 2, the integral from -1 to 5 of x minus 2 dx. So this is equal to, I need first an antiderivative of x minus 2. So an antiderivative of x, I need to increase the exponent by 1 and divide by the new exponent. And then for 2, I just throw an x on it, and I get 2x. Derivative of -2x would be 2. I need to evaluate this from -1 to 5. That means first plug in the 5, and then subtract what you get when you plug in the -1. So if I plug in a 5, I get 25 over 2, which is 12.5, minus 2 times 5 is 10. 12.5 minus 10 is 2.5. And then when I plug in a -1, I get 1/2 plus 2 is 1.5. And 2.5 minus 1.5 is 1. Okay, double check on the calculator. Math 9. Integrating from -1 to 5. The function is x minus 2 dx. 0. Okay, I messed something up. Oh, yeah, okay, so set subtraction. When I plug a -1 in, I get 1/2, 0.5. And when I plug in -1 into 2x minus 2x, I get plus 2. 0.5 plus 2 is 2.5. So this is 2.5 minus 2.5, which is 0. Okay, the integral from 0 to 3 of 2 to the x dx. So I need an antiderivative of 2 to the x. So if you remember the rule for derivatives, the derivative of a to the x is a to the x ln a. So this is going to be the reverse of that. So it's going to be 2 to the x over ln of 2, evaluated from 0 to 3. So first I plug in a 3, so I get 2 cubed over ln 2. Then I plug in a 0, so I get 2 to the 0 over the ln of 2. 8 over ln 2 minus 1 over ln 2 is 7 over the ln of 2. Check on the calculator. Math 9. Integral from 0 to 3. 2 to the x dx. It's giving me a decimal. I need to make sure that that decimal is approximately the same as 7 over ln 2, my exact answer. Same thing. Okay, so we got that one right. Number 4, the integral from 0 to pi of sine t plus cosine t dt. Start by finding an antiderivative. So I need a function whose derivative is sine of t. So that would be, well, the derivative of cosine is negative sine, so I need negative cosine. And then a function whose derivative of cosine is sine. And I need to evaluate that from 0 to pi. All right, so if I plug in pi, again, I'm just going to write it all out. Negative cosine pi plus sine of pi. And then plug in 0. Negative cosine of 0 plus sine of 0. Okay, so the cosine of pi is -1, but that's negative 1, so that's 1. The sine of pi is 0. The cosine of 0 is 1, so it's a -1, plus the sine of 0 is 0. So I have 1 plus 1, which is 2. Quick check on the graphing calculator. 0 to pi sine x plus cosine x. Notice I'm using x's, not t's, because my graphing calculator has an x button and not a t button. And I get 2. Good. Okay, continuing with the same kind of problem. These just have a little bit of algebra we have to do before we can start looking for an antiderivative. So first thing I'm going to do here is rewrite any roots as exponents, because I like exponents better because I can use the power rule to find antiderivatives. So this is going to be x to the 1/3 minus x to the -1/3 dx. All right, then I'm going to distribute that x in my integrand. So I have 1 to 8. That's an x to the first, and when you have like bases, you add the exponents. So this is going to be x to the 4/3 minus x to the 3/3 minus 1/3 is 2/3 dx. Now we need an antiderivative, so that means add 1 to the exponent and divide by the new exponent. So 4/3 plus 1 is 7/3, and I'm going to divide by 7/3 or multiply by 3/7. Add 1 to this exponent and I get 5/3, and dividing by 5/3 is the same as multiplying by 3/5, and I need to evaluate that from 1 to 8. Okay, so that means, what do you get when you plug in an 8? So this is 3/7 times 8 to the 7/3 minus 3/5 times 8 to the 5/3, and then plug in a 1. So that's just 3/7 minus 3/5. Okay, so I'm going to try to do some of these in my head. So 8 to the 7/3, well, I'm going to do the cube root of 8 first, so that's 2, and then 2 to the 7th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128. So that's 3/7 times 128 minus 3/5 times 2 to the 5th, which is 2, 4, 8, 16, 32, minus 3/7 minus 3/5. All right, I think it's time for a calculator. (3/7) times 128 minus 3/5 times 32. So as a fraction, that's 1248 over 35. And then I need to subtract 3/7 minus 3/5. 1254 over 35. Let's check it on the calculator. $35.82. That is about 1254 over 35. Same answer. Okay, good.